What if Earth wasn't orbiting the Sun? What if instead, our entire world circled one of the stars in Alpha Centauri, the closest stellar system to us? Imagine waking up to a sky that sometimes has two blazing suns instead of one. Imagine the nights lit up with alien constellations, brighter and stranger than anything we know. Imagine living in a solar system where home doesn't mean the sun at all. It sounds like pure science fiction, right? But let's actually think this through. If Earth somehow appeared in orbit around Alpha Centauri, what would change? Would our planet even survive in that environment? Could life still exist? And how would human civilization look if the stars we see today weren't teeny pinpricks of light, but overwhelming neighbors shining in our skies? To start, we need to know what Alpha Centauri really is. Most people think of it as a single star, but it's actually a triple star system. Alpha Centauri A, Alpha Centauri B, and a small red dwarf star named Proxima Centauri. Together, they form the nearest star family beyond our Sun, sitting just over 4 light-years away. If Earth were there instead of here, we wouldn't just be swapping one star for another. We'd be dropping into a completely different cosmic neighborhood. And that raises some incredible questions. How would our orbit change compared to the Sun's? Would we get strange, unpredictable seasons? Would the pull of two stars tear Earth apart? Or could it find a stable path between them? What would the night sky look like if Proxima, dim but close, glowed beside two blazing suns? Would our calendars, our myths, even our sense of time itself be rewritten by such a sky? And on a deeper level, how would living in such a system change our stories, our cultures, and our future as a spacefaring civilization? So what exactly is Alpha Centauri? At first glance, it looks like a single bright star in the night sky, especially if you're observing from the southern hemisphere. But in reality, it's not just one star. It's a whole system of 3 stars bound together by gravity. The main pair, Alpha Centauri A and Alpha Centauri B, are relatively similar to our Sun. Alpha Centauri A is a little larger and brighter, while Alpha Centauri B is slightly smaller and cooler. Together, they orbit around each other in a gravitational dance that takes about 80 years to complete. Then, orbiting far away from them is a faint little star, Proxima Centauri, a red dwarf that is the closest of the 3 to Earth. In fact, Proxima is technically the closest star to us besides the Sun. Now, if Earth were magically relocated into this system, the first big question is, which star would we orbit? Alpha Centauri A is the best candidate because it's the most Sun-like in terms of size and brightness. But Alpha Centauri B could also host Earth without too much trouble, although its slightly lower output of energy would mean Earth might be a little colder. Proxima, on the other hand, is way too small and unstable. It flares constantly, blasting radiation that would strip away Earth's atmosphere and make life nearly impossible. So let's stick with A or B. Picture standing on Earth's surface and looking up to see not one but 2 blazing disks. Maybe one larger and brighter, the other a smaller but still stunning light. Depending on where Earth's orbit lined up, this could happen often, or Earth could experience periods where the stars were farther apart in our skies. Either way, the sight would be absolutely breathtaking. This cosmic setup might sound magical, but it also creates some serious complications for Earth's orbit and for life itself. Could Earth actually survive in a system with 2 suns pulling on it at once? Binary star systems are notoriously tricky when it comes to stable orbits. Astronomers classify planetary orbits in 2 broad categories. S-type orbits are when a planet orbits just one of the stars, while the other acts as a distant companion. P-type orbits are when a planet orbits around both stars together, circling them as if they were one giant mass. If Earth orbited Alpha Centauri A at roughly the same distance we orbit the Sun, 1 astronomical unit, then Alpha Centauri B would still be far enough away most of the time not to disrupt things too much. That means Earth could maintain a stable S-type orbit. The year length would be almost the same, because Alpha Centauri A shines about as brightly as our Sun. We'd still get 365-ish days, still have seasons, and still have a habitable climate. But stability isn't guaranteed forever, Because Alpha Centauri A and B orbit each other every 80 years, the tug of gravity from the second star would slowly shift Earth's orbit over time. That means long-term climate cycles could become unpredictable. Every few centuries, Earth might drift slightly closer or farther from its main star, leading to ice ages or warm periods unlike anything in our history. Our planet's stability, the thing that allowed life to flourish for billions of years under the sun, would suddenly be a little less secure. Another complication: Earth's orbit could become more elliptical. Right now, Earth's orbit around the sun is nearly circular, which helps keep climate stable. But in Alpha Centauri, gravitational nudges could stretch Earth's orbit into an oval. That would mean periods where Earth was too hot, followed by stretches where it was too cold. Our climate might swing dramatically from one extreme to another, testing the resilience of ecosystems. Then, there's the matter of axial tilt. On Earth today, our 23.5-degree tilt is the reason we have seasons. But the presence of a second star could destabilize that tilt over thousands or millions of years. Earth's axis might wobble wildly, producing superseasons or even chaotic climate shifts. Imagine a world where the tilt swings so far that the poles point almost directly at the sun for decades, one hemisphere scorched while the other freezes. Then, centuries later, it flips. Life could endure, but survival would be far more challenging. Tides would also be chaotic. With two massive stars influencing Earth, ocean patterns could become unpredictable. Add in the gravitational pull of our moon, and you'd get powerful super tides that flood coastlines regularly. Early human civilizations, if they arose, might be forced to avoid coasts altogether, or invent flood-resistant structures much earlier than we did. Entire cultures could be shaped by the rhythm of two suns and a restless ocean. If Earth somehow took a P-type orbit, circling both Alpha Centauri A and B as a pair, things would look very different. The year would be much longer, because Earth would have to orbit farther out to keep stable. Seasons would stretch for decades, with long winters and long summers dominating life cycles. Humanity might build entire civilizations around enduring generations-long winters and preparing for the next great thaw. Our sense of time itself would be radically different. In short, Earth could survive in Alpha Centauri, but the ride would be a lot bumpier. We'd be trading stability for drama, a world where physics itself constantly reminds us of the cosmic dance overhead. And from the surface, the sky would tell the story of these strange forces shaping our world. Let's step outside for a moment. What would it look like if Earth orbited Alpha Centauri? Depending on Earth's position, you might see two suns rising at once, one larger and blazing like our sun, the other smaller but still dazzling. Sometimes the stars would move close together, almost like a double sun. Other times they'd drift apart, one sinking below the horizon while the other stayed overhead. Sunsets could mean one star disappearing while the other lingers in the sky, painting everything in surreal colors. At night, the view would be even stranger. Today, the stars we see are distant points of light. But from Alpha Centauri, our nearest neighbors would be blindingly bright. Imagine looking up and seeing Sirius, already the brightest star in our sky, but multiplied several times over. The Milky Way would blaze more vividly, but the brightness of the twin stars could wash out some constellations entirely. Night might never be truly dark. Proxima Centauri, while faint compared to its siblings, might still glow dimly red in the sky. It would be a constant reminder that our solar system wasn't mighty alone. We at D always see the third sibling star nearby. And think about eclipses. If Earth lined up just right, one star could block the other, creating double eclipses unlike anything we've ever seen. Instead of one shadow moving across the land, you'd get overlapping, shifting shadows, throwing landscapes into bizarre, otherworldly patterns of light. Meteor showers would also look spectacular. Two stars illuminating the sky could make streaking meteors sparkle brighter than anything we see on Earth today. Aurora displays, triggered by stellar winds from both stars, might cover entire hemispheres with glowing curtains of light. This view alone would reshape human imagination. From ancient mythologies to modern science, our relationship with the sky has always defined our sense of place in the universe. Two suns blazing in the heavens would inspire stories, gods, and entire cultures completely different from the ones we know. But could life actually survive under those skies? On the surface, the answer looks promising. Alpha Centauri. A provides almost the same amount of energy as our Sun. Temperatures on Earth would be similar, so liquid water could still exist, and photosynthesis could still power life. In fact, Alpha Centauri B's extra light might even help, adding brightness to the planet during parts of its orbit. But the dangers are real. The fluctuating gravity of two stars could destabilize Earth's tilt and orbit, creating climate extremes. Some epochs might see Earth freeze over, while others might turn it into a greenhouse world. Life would need to be extremely adaptable, capable of thriving in changing conditions. Radiation would also be a concern. If Earth got too close to flaring from Alpha Centauri b, or if Proxima's powerful stellar winds reached us, our atmosphere could be stressed. Thankfully, Earth's magnetic field would help protect us, but it's possible evolution would produce life with stronger resistance to radiation. Maybe even humans with biological defenses we can't imagine today. Ecosystems would evolve differently under two suns. Plants might develop pigments to capture a broader range of light, leading to strange colors in forests and oceans. Imagine red or silver leaves instead of green, designed to soak up every wavelength of light. Animal behavior might adapt to days that stretch and bend depending on when the sun's rose or set. Predators might hunt in long twilight periods, while prey evolved camouflage for two overlapping light sources. Microbial life would especially thrive in extremes. Radiation-resistant, heat-loving, or cold-enduring species might dominate Earth's biosphere. Evolution would likely accelerate under constantly shifting pressures, producing a planet full of bizarre adaptations. Life could exist, but it wouldn't look quite like the life we know here. It would be stranger, tougher, and endlessly adapted to the whims of a binary sky. Now let's push the scenario forward. Humanity. How would living in Alpha Centauri shape us? For starters, our myths and religions would look completely different. Ancient civilizations on Earth have always worshipped the sun, Ra, Helios, Amaterasu. But in Alpha Centauri, humans would grow up under two blazing gods in the sky. Duality, balance, and cosmic struggle would dominate our stories. Imagine religions built not around a single source of light, but two powerful beings battling or embracing each other for eternity. Some cultures might see one star as benevolent and the other as wrathful, forever shaping moral systems around this cosmic duality. Calendars and timekeeping would be more complicated too. Our 365-day year works because the sun's orbit is stable. But in Alpha Centauri, orbital shifts would create long cycles that humans would eventually track. Maybe our calendars wouldn't just mark years, but great epochs tied to the movements of the twin suns. Entire civilizations might measure time not in decades or centuries, but in star cycles lasting 80 years, the time it takes for A and B to complete their orbit. Daily life would change as well. If some days had twin sunrises while others only had one, cultures would adapt rituals around them. Imagine festivals during double dawns, when both stars rise together, celebrated as moments of cosmic unity. Farmers might plant crops only when one star was dominant, shaping agriculture around stellar rhythms. Science and exploration would also evolve faster. Living in a system where other stars were visibly close by would spark curiosity earlier. Ancient astronomers would not just see faint pinpricks, they'd see entire blazing worlds right overhead. The dream of traveling to other stars wouldn't feel abstract. It would feel urgent, immediate, within reach. Here's the fascinating part. Alpha Centauri is already the closest star system to us. If Earth were inside it, that would mean other stars, like Sirius, Barnard's star, or Wolf 359, would appear even closer. Space exploration could become humanity's central obsession because the cosmos would seem so much more crowded and alive. Contact with alien civilizations? Much more likely in our imaginations. Living with multiple stars visible would make the universe feel less lonely. Even if no aliens existed nearby, humanity might assume they did. That belief could fuel our drive to explore, to expand, to search for neighbors. Technology might accelerate too. Think about how much astronomy influenced the scientific revolution here on Earth. In Alpha Centauri, we'd have twice as much to study. twice as many celestial mechanics to explain. Physics and mathematics might develop faster, simply because humans would need better tools to understand the chaotic skies. On a more practical level, survival might demand innovation. If Earth's orbit fluctuated and climates shifted, humans would need to master agriculture in extreme conditions. That could lead to earlier development of greenhouses, climate engineering, or even space habitats. We might leap into the space age centuries ahead of schedule. And when it comes to spaceflight, the motivation would be stronger than ever. Imagine civilizations looking up and seeing Proxima glowing faintly in the sky. Even if it wasn't habitable, just the fact that another star was visibly close would drive humanity to reach it. Colonization efforts might begin much earlier in human history. The first telescopes might have been pointed not at distant planets, but at the glowing neighbors next door. Living under two suns would shape not only science and technology, but art, culture, and philosophy. Poets might write about the twin flames of the heavens. Painters might obsess over landscapes painted in double shadows. Philosophers might build entire systems of thought around duality, opposition, and cosmic harmony. The human imagination would expand under a sky that constantly reminded us of life's strangeness and beauty. So while Alpha Centauri would bring danger and chaos, it might also accelerate humanity's path to the stars. Living in a multi-star system could turn us into explorers much sooner than we did under the steady, predictable sun. So, what if Earth orbited Alpha Centauri? The short answer, we'd survive. But nothing would ever be the same. Our planet could circle Alpha Centauri A or B and stay habitable. But the gravitational dance of two stars would create chaos in our orbit, tides and seasons. Life would adapt, evolving strange new forms under the glow of two suns. Human civilizations would grow up in a sky of endless wonder, inventing myths and technologies shaped by dual stars and brighter nights. And perhaps, seeing other stars so close, we'd chase space exploration far earlier than we ever did. It's a reminder of just how finely tuned our place in the cosmos really is. The sun may look ordinary compared to its neighbors, but its stability is what allowed life to flourish here. In another system, Earth might have survived, but the path of history, of life, and of humanity itself would have been completely different. In the end, Alpha Centauri shows us both the fragility and the wonder of our place in the universe. If you enjoyed this journey, make sure to hit subscribe, leave a like, and share this video with a fellow space enthusiast. Until next time, keep looking up.